Hi everyone, this video is an exercise 11K question 5. So we have this differential equation dA by dt is equal to a to the power of 3 over 2 over 10t squared. And this is the rate of change of the surface area of a drop of oil at time t. And we are also given that the surface area of the drop is 1 millimeter squared at t is equal to 1. So in part A, we want to find an expression for A in terms of t. So part A is just solving this differential equation by separation of variables. So we can first divide both sides by a to the power of 3 over 2, and because that allows us to have a on the left, and then we can multiply both sides by dt. So we'll have 1 over a to the power of 3 over 2 dA is equal to 1 over t squared dt. But we can rewrite this as a to the power of minus 3 over 2 dA is equal to basically 1 over 10 t to the power of minus 2 dt. So that makes the integration easier. Now we can integrate both sides. So for the left hand side, we basically add 1 to the power and divide by the new power. So when we add 1 to minus 3 over 2, we get minus 1 over 2. So we divide this by minus 1 over 2, which is basically minus 2a to the power of minus 3 over 2. Well, not minus 3 over 2. The new power is minus 1 over 2 is equal to, so here is the same. We add 1 to the power, which was minus 1, and we divide by minus 1, which is minus 1 over 10 t to the power of minus 1 and plus c. So now we have an expression for a, which is also in terms of t, but still we need to make some adjustments, because first of all, we need to find the constant of integration, and also it's probably better to rewrite this in a form a is equal to something times t, because right now it's just minus 2a to the power of minus a half, which is a bit messy. So we can substitute t is equal to 1, and then when t is equal to 1, a is just equal to 1. So basically we'll have minus 2 times 1 to the power of minus half, which is just minus 2, and then here minus 1 over 10 times 1, which is minus 1 over 10 plus c. So c is equal to minus 2 plus 1 over 10, which is minus 19 over 10. Okay, now that we have found c, then we'll have this equation basically minus 2 over root a, because it's a to the power of minus a half, which is equal to root a, is equal to minus 1 over 10t minus 19 over 10. Now that we have this, what we can do is basically first we can simplify the right hand side. So minus 2 over root a is equal to, so we can take the denominator of 10t, and then we'll have minus 1 minus 19t. But if we multiply both sides by negative 1, everything changes to positive, so it just becomes positive for every term. And now we want to make a the subject, so we can multiply both sides by root a. So we'll have we can do cross multiplication first, so that gives us 20t is equal to root a times 1 plus 19t. And now let's divide both sides by 1 plus 19t. So we'll have root a is equal to 20t over 1 plus 19t. And finally, we just square both sides, so we get a, which is equal to 20t over 1 plus 19t squared. Right, so part B, which is interesting, we want to show that the surface area of the drop cannot exceed 400 over 361 millimeters squared. So when we see questions like this, it's normally about the limiting behavior of the function. And in this case, it's basically saying that what will happen to the value of a as t approaches infinity. So as t approaches infinity, then here basically we have 20 in numerator and then 19 denominator. So they're basically kind of very close. And then we also have 1 plus that. So if you just think logically, as the first term gets extremely large, also the bottom term gets extremely large, and they're almost very close, right? Because we are basically increasing both of them by the same number, and then as we basically approach infinity, this one gets insignificant. So roughly speaking, this approaches to just simply 20 over 19 squared. You can sort of think that the two infinities kind of cancel out. While that's not very kind of rigorous, but that's a very rough idea that you need to have at least for this A level. Um, and then this is basically equal to 400 over 361 as a limit.